Welcome to this explainer. You know, if you've ever sat in a science class, stared at a whiteboard, just absolutely covered in formulas, and wondered who on earth came up with these seemingly random letters in physics equations, well, you are absolutely not alone. It's kind of a universal struggle. Okay, let's dive into this because today we're going to decode one of the most famously confusing symbols in the whole shebang of physics, the letter S.
I mean, it's an incredibly logical question to ask, right? If the word distance starts with a D and gets the symbol D, why on earth does displacement, which obviously also starts with a D, get assigned the letter S? On the surface, it feels like a typo. Just a mistake that somehow survived for centuries, because it completely defies our basic intuition. But as we're going to see, there's actually this fascinating historical and mathematical detective story behind this choice. It wasn't an accident. It was a deliberate, totally necessary decision.
Part 1. The ancient Latin connection. We really got to look to the past to uncover our very first clue. So the answer actually starts with the word spatium. In the early days of scientific discovery, brilliant minds like Isaac Newton, they weren't writing their foundational papers in English. The universal language of science back then was Latin. And in Latin, the word for space, distance, or a physical interval is spatium. Early physicists simply took the very first letter of that Latin word, so that S we use today, it's actually this elegant ancient legacy just hiding in plain sight right inside our modern textbooks. Let's move to and see how this builds into Part 2, Escaping the Calculus Trap. This is the practical, mathematical survival reason we desperately needed to avoid the letter D. Okay, to really understand this mathematical trap, let's look at a foundational concept, velocity. Simply put, velocity is just the change in displacement over a change in time. But when we start dealing with these changes in physics, we enter the realm of calculus, specifically differentials. And in calculus, we use a lowercase d to represent that change in a variable. Now, you can probably see how this creates a massive problem. Now, what's really interesting about this is the sheer visual absurdity if we actually forced the letter d into this. The formula for velocity using calculus differentials would literally be written as v equals dd over dt. I mean, imagine trying to solve complex equations with a double d floating around. Anyone would look at that and wonder, wait, is that a typo, a single weird variable, or just a massive mistake? Actually, scratch that, it's an absolute nightmare for clarity. But by using the s from spatium, the formula becomes v equals ds over dt. It's clean, it's crystal clear, and it completely saves us from calculus confusion. Which brings us to Part 3, distance versus displacement. Let's look at the actual physics superpower of the symbol S and why it requires its own unique identity. And this brilliantly illustrates the core difference between the two. Distance is simple, right? It just tells you how much ground you covered, kind of like counting your steps on a smartwatch. It doesn't matter if you just walked in circles. But displacement, our letter S, is a vector quantity. It's highly specific. It demands to know the absolute shortest path from your starting position to your ending position, and crucially, it includes the direction. Distance is just a number. Displacement S is a powerful vector requiring precision. It tells you exactly where you ended up relative to where you started. Moving right along to Part 4, predicting exact future positions. Let's bridge the gap between this theoretical math and some pretty awe-inspiring real-world application. Behold, one of the most famous equations of motion. So the crucial point is that this formula isn't just a string of letters for you to memorize for a test. It is literally the ultimate tool for predicting the future. This equation calculates displacement. It's the mathematical engine that allows scientists and engineers to look at a moving object and say, with absolute certainty, I know exactly where this is going to be. Let's ground this abstract math in an exciting reality. Imagine you're tracking a rocket blasting off into the atmosphere. How do you know exactly where it's going to end up? We only need to know a few key pieces of information. If you input the rocket's acceleration, represented by a, and you input the time it's been traveling, represented by t, the equation just works its magic. The output? Our trusty letter S. You get the rocket's exact final position and direction. The symbol S isn't just a letter. It represents the exact trackable destination of a particle, a car, or even a spacecraft. It's pretty incredible to think about, isn't it? We use the exact same symbol to plot a path to the stars today that was born out of an ancient language thousands of years ago. So the next time you track a rocket's path, or even just crack open a physics textbook, will you remember the ancient Latin word spatium that makes perfectly clear, confusion-free mathematics possible? Thank you so much for joining me for this explainer. I really hope this helps clear up the mystery of these spas once and for all.